Hello, and thank you for joining me again as we wrap up my unit on moles. We're going to talk about empirical formulas, empirical and molecular formulas, and there's something to be said for these. So for starters, things I want you to be able to do. I want you to be able to determine the empirical and molecular formula for an unknown substance, and that's going to involve some steps and some processes, but I want you to be able to tell me the difference and be able to determine what they end up being. So looking at these two examples, we have C2H2 and we have C6H6. You will notice that the ratio of carbon to hydrogen in this one is 1 to 1, or 2 to 2, which can be reduced to 1 to 1. In this one, it's 6 to 6, which can also be reduced to 1 to 1. So these have the same ratio, which is the same ratio of carbon to hydrogen atoms. And we can get these down to their smallest whole number components, whole number ratios, which is 1 to 1. This is what we call an empirical formula. Okay, so these types of formulas are called empirical formulas. This is the compound. It's the simplest whole number ratio of ions or atoms in a formula unit to the simplest ratio of atoms in each element in a molecule. Okay, so smallest whole number ratios of subscripts in a compound, elements in a compound. The actual molecular formula must be the multiple of the empirical formula. So your actual molecular formula has to be a multiple of the empirical, and this is kind of what we're going to. So you can calculate and determine and find this empirical formula. So you're going to be given a problem, and it's going to give you this percent of a compound was carbon, this percent was hydrogen. Okay, if they give it to you in percent, you're going to give this as grams. You're going to assume a 100-gram sample. And that's how we can go from percent to grams. We just assume it's a 100-gram sample because your percents have to equal 100, then your grams will all equal 100. We're going to convert those values into moles. We're going to determine the smallest mole value and divide each by the smallest value. And you're going to determine the smallest whole number ratio, and then those will qualify as subscripts. So some real basic steps I like to think of. So step one, you go percent to grams. You just change percent into grams. Step two, we have to go from grams into moles. Step three is divide by smallest number of moles. Step four, determine ratio. You're going to either round or multiply to get whole numbers. And step five, write subscripts. Okay, so this is the process we're going to be going through. So this example, hydrazine is a compound used in rocket fuel. Its percent composition is 12.58% hydrogen, 87.4% nitrogen. Determine the empirical formula for hydrazine. So we start by assuming we have a 100-gram sample. If we have a 100-gram sample, that means we have 12.58 grams, 87.41 grams. So we went from grams to percent to grams. Step one, done, check. Okay, step two, the one we're going to get on the next slide. We're going to go from grams into moles. And remind yourself how we do this. So to go from grams to moles, we have to divide by the molar mass. So in this case, we're going to divide hydrogen by 1.01. We're going to divide nitrogen by 14.01. And that's grams per mole. Okay, and so that's shown to you here. Again, I didn't do the 2 decimals, but it's going to be really close. So you get 12.58 divided by 1 is going to give you 12.58 moles of hydrogen. 87.41 grams divided by 14 gives you 6.41 moles of nitrogen. Okay, if you look at these two, 12.58 is bigger than 6.24. So then you're going to divide by your smallest number, which in this case is 6.24. Anything divided by itself is going to be 1. 12.58 divided by 6.24 is going to come out to not exactly 2. 0.24. I get 2.016. In this case, that is small enough that we're going to round that down to 2, and that's where we get this number. And so then 2 becomes my subscript for the H, which is here. 1 is my subscript for the N, so that is my empirical formula for the compound. Okay? And so this one, we have a compound containing only phosphorus and oxygen with a percent mass distribution of 43.66% phosphorus and 56.34% oxygen. Determining our empirical formula, we're going to step 1, change percent to grams. We're going to have 43.66 grams of phosphorus. We're going to have 56.34 grams of oxygen. Step 1, done, check. Next step, go from grams to moles. Good. Going from grams to moles. Remind yourself how we do this. Okay, so now we have to convert into moles using our molar mass. So 43.66 grams of phosphorus divided by that 31 grams of phosphorus. Same with 56.34 divided by 16. Okay, we're going to get 1.41 moles of phosphorus and 3.52 moles of oxygen. Okay, so we went from grams to moles. Next step is going to be to divide by that smallest number. So I'm going to divide both numbers by this 1.41. And so for moles of phosphorus, this is going to be 1. If I divide 3.52 divided by 1.41, I'm going to get 2.496, 2.50. Okay? Now, because I have 1, I have 2.5. When you're taught when you're younger, if it's 0.5 and up, you round up. 0.49 and down, you round down. Okay? In this case, because this is 2.5, we can multiply to get our whole number instead. And so 2.5 times 2 is going to give you 5. But if we do something to one, we have to do it to the other. So this times 2 is 2. So we have P2O5 is going to be my empirical formula in this case. Okay, on these numbers you're going to look for to multiply. Your 0.3, we can go 33 is a third, 0.25 would be times 4, 0.125-ish is going to be times 8. So this is going to be times 4, this is times 3, this is times 8. If you have 0.66 or something close to it, you take it times 3 as well. Those are kind of your big ones. Those are your most common. 0.75 is a possibility, but again, on that one, you have to take it times 4. So these are some decimals you want to look for. You're not going to round these. You're going to multiply these guys, okay? And multiply both of them by the same number. So 0.25, you're going to round both of them, multiply both by 4. 0.33, multiply both by 3, or everything times 3. Everything times 8, times 3, and times 4. But everything has to be done the same for both particles in the substance. Okay, now if we're going to determine our molecular formula from the empirical, this time we can use the molar mass. We can determine the empirical formula, which we talked about. We've already done. Then you're going to calculate your molar mass or formula mass for your empirical formula. You're going to divide your molecular mass by the empirical mass and multiply your subscripts from the empirical formula by the ratio obtained from the masses. So let's try this out. The empirical formula for styrene is CH. Its molar mass is 104 grams. Determine the molecular formula. Okay, so we know that the empirical formula is CH. So now we need the empirical formula molar mass, empirical formula weight. Okay, so we have CH is 13.0 because carbon is 12.01, hydrogen is 1.01, so I would tell you it's 13.02, but that's close enough there. Styrene, it says 104 grams. So now we're going to take our 104, big number divided by small number, divided by 13.02, and we should get roughly 8. So 104 divided by 13 actually comes out to 8 on the dot. Okay, so now you get this number. You're going to multiply your entire empirical formula, which is CH. Take this whole thing times 8, so it's got to distribute. So we get C8, H8 as our molecular formula. So this is my molecular formula. Okay, so it's going to be really important. You have to be able to solve for this empirical formula. Most of the time, I'm not going to give this to you. And then you have to work from there to get your molecular formula by dividing your two molar masses like we did here. Okay, empirical formula for a substance is CH2O. If your molar mass is 90 grams, determine the molecular formula. So we know carbon is 12, hydrogen is 2, oxygen is 16, so my formula weight is going to be 30. We're going to take, that's my molar mass of your empirical formula is going to be 30. We're going to take big number divided by small number. 90.0 divided by 30. 9 divided by 3 is going to be 3. So I'm going to take CH2O, I multiply the whole thing by 3, and I'm going to get C3H6O3 as my molecular formula as shown here. Okay? So that's my empirical molecular formulas. A lot of times we use this in science in combustion reactions, and we'll talk more about those later on. But combustion is kind of a big place we can use this empirical molecular formula information. Okay? The last little bit's going to be on hydrates. So hydrates are compounds that contain water as part of their molecular structure. Actually, this is going to be in the next video. We're going to be done with this for now. So this is your molecular empirical formulas. I hope that you learned something in regards to this concept today, and I look forward to working through the rest of the unit with you when we talk about hydrates to round things out. But thank you for your time and attention, and enjoy the rest of your day. Bye.